Hello, this is Mrs. Scoville, and today we are learning all about anaerobic respiration. This is still Unit 5, Flow of Matter and Energy. We have three objectives for today's lesson. The first is to see how glycolysis and fermentation are connected. The second is to compare and contrast aerobic and anaerobic cellular respiration. And finally, to identify which pathway will happen in the cell based on oxygen availability and also the organism that it's happening in. All right, so a little bit of review. All of the cellular respiration that we have been learning up to this point is considered aerobic because it requires oxygen. So as a reminder, there were three steps: glycolysis, the Krebs cycle, and the electron transport chain, making a total of 36 ATPs. Two of these steps, the Krebs cycle and the electron transport chain, aka oxidative phosphorylation, directly require oxygen in order to occur. Glycolysis, the first step, didn't require oxygen, but because the whole process requires oxygen, it is considered aerobic. Anaerobic cellular respiration, on the other hand, is going to happen when there is not oxygen available. So we say this is without oxygen or it's anaerobic. This is still going to require glucose, just like aerobic respiration did. So you can see here we've got like a little diagram of anaerobic respiration, and you do have to have glucose to start it off. However, there are only going to be two steps. The first is still glycolysis, because glycolysis itself does not require oxygen. So this is still the same process that we saw before, where you're going to make two ATPs and you also make NADH. But the second step is going to be different. And the second step is called fermentation. There are two types of fermentation. The first is lactic acid fermentation, and the second type is alcoholic fermentation. So again, anaerobic cellular respiration only has the two steps. And you can see here basically already kind of a hint about what's going to do at yeast or bacteria. Fermentation, that term, specifically means to make energy from food by just making ATP without oxygen from the food. So this is much less efficient than aerobic respiration. Overall, fermentation only makes two ATPs at any time using glycolysis, which made two ATPs on its own. And again, this is only going to be something that you're going to do if there's not enough oxygen, because remember, aerobic respiration made 36 ATPs, which is much more desirable than making two. So the conditions under which you would be doing fermentation, again, are low oxygen. And an example of this is in humans. So in humans or any animal, when you're rapidly exercising, so for example, people running a marathon like we see right here, they are going to be breathing in a lot. However, they are not going to be able to get enough oxygen to their cells very quickly to continue completing aerobic cellular respiration. So in this case, people do fermentation as well, and no, this does not mean you have alcohol in your muscles because you're creating lactic acid. And what lactic acid fermentation looks like is, well, this. You continue to take the pyruvic acid that you create in glycolysis, and instead of using it in the Krebs cycle like you would in cellular respiration, you make lactic acid. And if you've had a really hard workout and you're really sore the next day, that's because you couldn't get enough oxygen to your muscles, and you got a lot of lactic acid, and that makes your muscles ache. So our formula here is pyruvic acid plus NADH, which is made during glycolysis, creates lactic acid and NAD+. The NAD+ will be recycled back. It's going to keep glycolysis going, and it'll make two ATPs each time that it goes through it. So we can see this is a loop. Essentially, you still start with glucose. You still have to have that input of energy from food. You'll use the two ATPs to get it going. Pyruvate will be produced, and then you're going to, instead of going on to the Krebs cycle, the NADH that you produce will be used to help produce lactate, which is right here, which is lactic acid. So again, you're not going to have that positive feedback into the Krebs cycle to help keep cellular respiration going. Instead, glycolysis essentially forms its own loop. The other type of fermentation we have is alcoholic fermentation. So this will be carried out by a lot of bacteria and yeast. The thing that's interesting is the alcohol product that's produced is toxic to these organisms. So if the alcohol level gets too high, it will kill the bacteria or yeast. There are a lot of uses for this that are really positive. If you enjoy bread, you're enjoying a product of fermentation because this is going to cause bread dough to rise. Yogurt and cheese, if you eat yogurt and cheese, that's also alcoholic fermentation that's helped to make it taste that way. Additionally, alcoholic beverages are made through fermentation, which, guess what, they're called alcoholic beverages for alcoholic fermentation. This is going to have a very similar formula, although there are some very important differences versus lactic acid fermentation. So again, pyruvic acid or pyruvate You're going to have an input there with the NADH as well, and this is going to produce alcohol, CO2, and NAD+. So the big difference here is the product of CO2. So CO2 is a way that you can tell that you are having alcoholic fermentation instead of lactic acid fermentation. For our bread back here, that's going to be really important because the CO2 bubbles are what help it rise. Again, similarly before, NAD plus will be recycled back. It keeps glycolysis going. Everything else here is the same. It makes 2 ATPs, but you can see it looks a little bit different. So here, instead of pyruvate immediately being turned into ethanol, there's kind of an intermediate form here. And again, you don't need to know like the exact name of this, but that is what's going to lead to the production of ethanol, again using NADH. So really the key things with fermentation are, again, you must start with glucose. You still make the pyruvate because you go through glycolysis as normal, but instead of moving on to the Krebs cycle, the pyruvate is reused in a different way, leading to the production of ethanol. Now, you may be asking, why is the cell even doing this? Well, if it's only going to make 2 ATPs, well, 2 is better than none. So if your cell needs energy, it would rather kind of sacrifice glucose for only 2 ATPs than to make no energy. And again, remember the key difference with alcoholic versus the lactic acid was the CO2. All right, so if we overall compare aerobic versus anaerobic respiration to compare them, as a reminder, aerobic uses oxygen. It makes up to 36 ATPs and it's pretty quick. It had 3 steps: glycolysis, the Krebs cycle, and the electron transport chain. And remember, the Krebs cycle is also known as citric acid cycle, and the electron transport chain is also known as oxidative phosphorylation. And this is going to happen in the cytoplasm and the mitochondria. And it always has the formula C6H12O6 plus 6O2, and it looks like little subscripts are getting cut off, but that's okay, plus 6 CO2 plus 6 H2O. This is not the anaerobic respiration, on the other hand, is not going to use oxygen. It will make ATPs quickly, but it's only going to make 2 at a time through glycolysis. This only had 2 steps, just glycolysis and fermentation. And remember, there are 2 types of fermentation. This is only going to happen in the cytoplasm. And I didn't mention this before, but you should know this because it's only glycolysis essentially repeating in a little bit different way. So this is only in the cytoplasm. And the formula that you would give it depends on the type of fermentation, whether it's lactic acid or alcoholic. So as a reminder here, what this looks like overall, if you have oxygen, so aerobic, pyruvate, which is produced during glycolysis, will be turned into acetyl-CoA, which goes into the Krebs cycle, and then further to the electron transport chain. In that case, you're using NADH, or sorry, you're producing NADH from NAD in the production of acetyl-CoA. Over without oxygen, though, you're not going to continue to the Krebs cycle. Instead, you'll include to either lactic acid, here the lactate, or the alcoholic fermentation pathway, again, depending on the individual organism. In both cases, you are using the NADH instead of creating it from glycolysis to directly power the fermentation, be it alcoholic or lactic acid. So again, the main difference there is just, are you going to continue to the Krebs cycle, or are you making some kind of product, be it lactic acid or ethanol, both which aren't that great. And then the final thing to note, again, remember the alcoholic one makes CO2. All right, so with that, now we get to have a little fun. I'm going to play a little song for you. It's called Gotta Get That ATP song, and it summarizes a lot of cellular respiration, including aerobic and anaerobic.
You break the bond between and release it. I like that ATP. oxygen. Welcome to the mitochondria. It's the citric acid cycle. 2 more ATP. Delightful because we got the oxygen. We got the ATP. We're in the place for the powerhouse to make that energy. Organisms in the world. If you want more ATP, better get ready for the next step. Electron transport chain. Yup, yup. I've been making that ATP. I've been making that ATP. Here we go, electron transport. We're making lots of energy. This is a step of respiration that makes 32 ATP. That's a whole lot of ATP. Let's add up the ATP. That's 2 to 32. That's 36 ATP. Let the glucose rock. Let the glucose rock. Let the glucose rock. 2 to 32. That's 36 ATP. I like that ATP. It's used for energy. Wanna do a cell process? You gotta get some of these. I'm so eukaryotic. You're so prokaryotic. I got that ATP. That future ATP. Let me get it now. ATP. Gotta get that ATP. Get that ATP. Gotta get that ATP. Gotta get that ATP. That ATP. That ATP. ATP. Let the glucose rock. Let the glucose rock. Let the glucose rock. Let the glucose rock. This was a Mr. Morin original. Stay tuned.
Okay, I hope you really enjoyed that Gotta Get That ATP song. At this time, it is the moment to write your complete summary using the summary frames in your lesson and be ready to practice the material.